Dear Grade 11, in today's video we're going to complete what we started about the carbonyl groups, aldehydes and ketones. In the previous video we started to learn how to differentiate between carbonyl group, aldehydes and ketones. So the first test was the Fehling test, and we have learned that in Fehling test you have Fehling is Fehling A and Fehling B. They are mixed together, and to differentiate between aldehydes and ketones, in aldehydes, because there is hydrogen, so they are easily oxidized, so instead of blue appears a brick red color. For ketones, nothing happens because there is no hydrogen to be oxidized. Again, let's take a look at the learning outcomes. Distinguish between aldehydes and ketones using Fehling. And today we're going to learn about the Tollens reagent. Okay. The Tollens reagent is also one way to differentiate between ketones and aldehydes. So how is it? Or what is the Tollens reagent? The Tollens reagent is diamine silver ion. This is the chemical formula for it. Again, it's diamine silver ion. There. So this Tollens reagent, when you react it with ketones, nothing happened. It's a colorless solution and stays colorless. But with an aldehydes, the colorless solution produces a gray precipitate, and we call that the silver mirror test. Okay, it looks like there is a silver mirror on the test tube, of course, from inside. So this is another way to differentiate between ketones and aldehydes. What is the other reagent? The Fehling, and Fehling is divided into two, Fehling A and Fehling B. And the blue color goes to the copper sulfate, right? So for this one, the Tollens reagent, you have a diamine silver ion, which is colorless. With ketones, it stays colorless, means there is no change, there is no reaction. In aldehydes, the colorless solution turns to a gray precipitate of silver. And this silver is called a silver mirror test. Now let's take a look at the experiment in this video. The Tollens test. Okay, you take 6 millimeters of silver nitrate are added into a clean test tube. And then the ammonia solution just drops, and again, just see, it's becoming colorless again. The silver oxide reacts with the ammonia to form a complex, the ones you need, diamine silver ion. The solution is called Tollens reagent. So this is how to make the Tollens reagent to test for aldehydes and ketones. Then the water-soluble substance can be added. You can add water, the solution, and you have to mix the solution very, very good to make sure that everything is mixed. The solution is mixed. Then the test tube is heated. You have to heat the test tube. There. As you can see the silver mirror is making? Yes, when you're adding sugar, because sugar actually contains aldehydes. Here, the aldehyde group 1 of glucose oxidized become carbonyl group. The silver ion from the complex is reduced and precipitates, which is the silver. The silver precipitates, making this silver mirror. With this reaction, Silver mirror completely can be removed by the water bath. From the water bath, it means you can separate actually the silver mate. The silver mirror can be separated. You can remove it. The glucose solution had been used. Okay, you're making 1 gram and 9 milliliter of water there. And the test tube, you rinse it of water 3 to 2 times. The solution inside, of course, without the silver. The solution again is heated with a water bath at degree more than 70. The glucose in large excess, so the rest of the silver here, sorry, see, excess absorbic, yes, aldehydes can be also used. You can use anything that have an aldehyde. One example of them is sugar. The silver can be filtered. There is the silver, can be filtered or disposed. The silver can even be turned back into silver nitrate. You can reuse it one more time. The surface of the glass can be cleaned if the mirror should be constant. You have to clear it or it will stay there. This is an example of a test tube that has the mirror surface and it wasn't cleaned. Okay, last thing or last reaction in this chapter here. How to do CH3CO compounds react with alkaline aqueous iodine. Okay, let's check that. Iodine is added to aldehyde or ketone solution. Just enough NaOH is added until the iodine is decolorized. A pale yellow precipitate of triiodomethane, CH3I, is formed. So this is what happened when CH3CO, which is, what is that? This is a ketone, right? Iodine can be added to aldehyde or ketone, both of them. Just enough sodium hydroxide is added until the iodine is chlorized. What is the color of iodine? Actually, the iodine looks like a little purple, okay, or brown. Decolorized, yes, brown, so a pale yellow precipitate of triiodomethane, CH3I, is formed. This is the chemical equation. Of course, R is an alkyl group, so you can replace it with CH3 or whatever alkyl group, plus iodine plus sodium hydroxide gives RCOO. What is COO? This functional group refers to. COO is, yes, this is, OO is called carboxylate group. And this is the, here, CH3, CH3I. Here it's iodomethane, sorry. It's iodomethane plus NaI, iodosodium, and water. That was the end of that chapter. And hope you're just taking it seriously. And in this chapter, or in this video, we ended with the Tollens reagent, and we said that aldehydes and ketones are different because they react differently because they have different functional groups. For aldehydes, you have hydrogen; in ketones, just CO, which is the carbonyl group. And the silver mirror test and Fehling test to differentiate between aldehydes and ketones, like here. For the Fehling test, the previous test that we have seen, the last video or the previous video, in that the ketones also does not change. The blue color of the Fehling stays blue, And in aldehydes, the blue color turns to red brick precipitate or color, which is the color of the precipitate. And in Tollens reagent, again, for ketones there is no change, and this time we're using the diamine silver ion. And this colorless solution for aldehydes also change, right? And turns to the silver is precipitated and making a silver mirror, and that's why they call it the silver mirror test. Hope you're staying safe and well, and see you soon.